everybody. Today we're going to get into some triangle um, congruence theorems, postulates. The first one is side, side, side. We're going to talk about that one. We're going to work some examples over what side, side, side means, where it's used, what we use things for. What we're trying to do for the next few days is prove that triangles are congruent. We've gone over a lot of properties of triangles. Now we need to prove that two triangles are congruent by several different methods. First one is going to be side, side, side. Okay? Let's take a look at it. The side, side, side postulate says if three sides of one triangle are congruent to three sides of a second triangle, then the two triangles are congruent. And hopefully that makes sense. That if all three sides are congruent to three corresponding sides in the second triangle, then the triangles are congruent to each other. They have to be. They're the exact same triangle. Okay? Now let's take a look at things. Decide whether the congruence statement is true. So let's put letters here. Let's go A, B, C, X, Y, Z. Are those two triangles congruent? And if so, how do we say it? Well, we say triangle A, B, C is congruent to triangle X, Y, Z by side, 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 because all the corresponding sides are congruent. They all equal the same thing. Okay? Let's take a look at this example. Are these two triangles the same? Now let's give letters here. A, B, C, D. Are those two triangles congruent? Well, this is okay. This is a reflexive property. Everything's good to go there. And BC is congruent to AD. Everything's good to go there. Our problem is right there. Those are not the same, so these two triangles are not congruent. Because not all three sides are congruent to the three sides in the other triangle. Okay? These two triangles. Let's go again. Let's go A, B, C, D, E. Are these two triangles congruent? Yes, they are. Side, side, side works here. So our statement would be triangle A, B, C is congruent to triangle. Now remember, order matters, so it's going to have to be E, D, C by side, side, side. Okay? Now another common example, and I didn't draw it in here, that happens a lot is if you have something like this. Are those two triangles congruent? Yes, they are. Because, let me get a different color. Because this side is congruent to this side. BC is congruent to AD. And AC is congruent to itself because AC is in both triangles. And there is a situation where you need the reflexive property because it's got to go both directions. So I can say triangle A, B, C is congruent to triangle. Now remember, order matters. So it's going to be C, D, A. Okay? Good. Next example. Which of the coordinates of the vertices of the triangle are congruent to triangle PQR? And I didn't put these in here. I believe it goes PQR. Okay? Well, let's take a look at this. We can graph, we can use the distance formula. I would say let's go ahead and graph and take a look at what we're seeing here first. So, let's see, I go to -1, 1. Go to -1, 5. 1, 2, 3, 4, 5. And I go to -4, 1, 2, 3, 4, 5. So there's one of these triangles. Okay. Now I go to -2, 4. 1, 2, 3, 4. -7, 1, 2, 3, 4, 5, 6, 7, 4. And -4, 1, 2, 3, 4, 6. 1, 2, 3, 4, 5, 6. Okay, we'll put this triangle in a different color here. Alright, good. Let's go blue with the next one. -3, 2, 3, up 2. -1, up 3. And say in blue here, let's go negative 7, 7, negative 7, 9, and negative 3, 7. That one might be closer, okay? Well, let's take a look at this. I'm looking at length. Length of PQ is 4. Length of this is 3. Okay? And because of Pythagorean theorem, I know we'll get there, but I know that this is going to end up being 5. So as long as I got a right triangle where the lengths are 3 and 4 of the legs, we're going to be okay. Well, this one doesn't work because that's 2, and that's 4, so we're close, but we need it to be 3. The one that ends up working is this red one here. Okay, so it's the first one. Because I have 4 here, I have 3 here, my hypotenuse is going to end up being 5. I know I got a jumbled mess, but this is the answer here. And we could prove it, and you'll have to prove it using the distance formula. Okay? And again, distance formula here, okay, should be review, is x1 minus x2 squared plus y1 minus y2 squared equals d squared. Comes from the Pythagorean theorem. Okay? That's all we had. It's a fairly basic chapter. This is probably the easiest thing to use to prove triangles are congruent side, side, side. We'll get into several more here as the year goes, as the week progresses. Hopefully this makes sense, and we'll see you in class.